Hello, everybody, and welcome to today's vOLTHA TST call. Thanks for joining, and as usual, the call is public and recorded and will be shared on YouTube, so please be mindful of whatever comments and information you share. It's going to be live. So first topic, after having said that, is that since Thursday last week, we did start the 2.5 branching and tagging, and we had a code freeze until yesterday. As of right now, master is open for changes because we do have branched everything that we needed. There are not yet the jobs for testing 2.5. Those are going to be created in these few days. What I would like everybody to do is to take a look at the list I have linked over here, which is this one. And if anybody has anything that is not needed for 2.5, in terms of bug fixes or tests, those are the only thing that are going to go in. Please do remove it from here. So whatever functionality didn't make it into 2.5, it's fine. Just make sure, go through this list, and anything that is assigned to you that it's not going to make it in 2.5 because it's not a bug or it's not a test, please do move it to either 2.6, which we have created, or future, and then you can grab from future and put it in 2.6 if you get some time in the upcoming months. Again, the target for the release is September the 30th, and we're going to use these 2-3 weeks to do some testing and make sure that everything works smoothly for the 2.5 release. So that's the first topic. Serve, anybody?
Andrea, just one thing. This time there is a difference in the way we prepare the release compared to 2.4. That means that we're going to lazy branch the repositories as needed. So if you need to make a bug fix on a repository that doesn't have a vOLTHA 2.5 branch, just let me know and I can help you create it.
Yes.
Why are we doing that lazily?
Because we're lazy.
Okay. That's
a fine answer. Yes, so either ping Matteo, ping me, and we can discuss. There are some things that already have a 2.5 branch. For those that don't, please do follow Matteo's suggestions.
But they have a 2.5 tag, but not a 2.5 branch. How would I check out 2.5 without a branch? I guess the question is.
So there is a tag on the release, sorry, on the branch, and we're gonna start the support branch from there if we need to do a bug fix on that repository. We decided not to create all the branches up front because in 2.4 we ended up only needing 3 of them and we created 15. So that was a fair amount of time that we could save.
So
okay.
And the tag that is the one for vOLTHA 2.5 is the one that you find in the Helm chart, and I'm gonna tag the Helm chart today.
Okay.
yes, so as of right now, if anybody wants to test 2.5, as usual, the kind vOLTHA repo has a releases vOLTHA 2.5 file, and this has all the elements that, all the versions that we do have at the moment tested in 2.5. Bear in mind, this is not the final release. These are going to change from now to September the 30th, and we're going to change them in this file. But this is the most up-to-date thing that you can find for the 2.5 that we are currently testing. Okay. So anything else that anybody wants to add or any questions for the 2.5 stuff? Okay. Awesome. Then next up on the list is something that was postponed from last time, and it's an investigation of secrets for gRPC encryption. So all of this stemmed from a requirement of securing the OpenOLT adapter to OpenOLT gRPC interface. Currently, at the moment, this is not encrypted in any way. It's not secured in any way. And there's a couple of Jira stories that are assigned to Hardik at the moment. I'll find the numbers. And those make us think about what is needed in terms of certificates to secure end-to-end a gRPC connection. We're going to start with the OpenOLT to adapter connection, but this can apply in the future to the gRPC investigation that Ken is doing, or for vOLTHA too. So I'll let David has given some thought to this. So I found a pretty useful tool with this which is called this Cert Manager that allows you to get certificates from many different issuers. Can be a sub-science certificate, CA certificate. It can be get from any of these, and it's an official Kubernetes project. It has a kubectl plugin to manage the certificates and the Cert Manager itself. And I think this is a very good base, but I'll leave the floor to David, who has given some thought to this and has started some investigation around this.
All I have looked at is the Java Web Token Service, JSON Web Token Service, or whatever it is. Basically, is a way to pass certificates around for gRPC, and the idea really was around don't write a password manager in your application. Use certs because there's mechanisms to manage those already. I haven't looked at the projects you referenced in terms of the Kubernetes Secrets Manager. That may be a perfectly viable reason. My main push was let's not build our own password manager because there's already mechanisms to deal with certs in gRPC. Let's just leverage that. So I think we should look at what you suggest. If it fits, let's go for it.
Yeah. So what I did some investigation of this, and I do believe this precisely fits what we need to do. We would then need to, this would then be need to deploy it to kind of vOLTHA, obviously, and deploy it as part of our deployment. Then the certificates need to be inserted. We could get some self-signed certificate for testing or something else for now. And then you would need to fetch these certificates within the different pods and mount them. And then the code needs to read those certificates and use them within the gRPC channel creation. So what I would suggest is if anybody has any interest, please do take a look at this this project. It's the official certification manager for Kubernetes. And also do take a look at some of these things that David set up. I would really like to come to a decision if this is the right tool very soon, because this is needed for completing some of the tasks that are required for production deployments around our operators. So this is fundamental, I would say. Any questions, any comments? No? Okay. Then please do take a look at that. And I guess we'll make the final decision next week. But if I don't hear any objections, this is probably going to be the way we go forward with. unless during this week we find out that this is not really something that we can use, but I believe not. Okay. So next topic that we have on the agenda for today is the investigation that Ken did on the move from Kafka to gRPC. Ken, do you want to take this over from myself and present what you found?
Yeah, sure.
Thanks.
Let me share my screen here. Can you see my screen?
Yes.
Oh, okay, perfect. Increase that. So, in vOLTHA 2.0, when we first designed it, we introduced Kafka between the core and the adapters, and also between adapters communications. And the main reason we had that, it was really to introduce HA and also to have Kafka message persistence. HA, why? Because at that time we had two cores that were working in pairs. It was much easier to set up topic groups or to have two core listen to the same set of messages and get the same set of messages. So Kafka was really a multi-point to multi-point communications, and in that kind of architecture, it works quite well. Now with the change that we have done, where we are putting everything in stacks, and we'll have one core that goes typically to one or multiple adapters. And we are really moving away from a multi-point to multi-point communications to a point-to-point communication. So doing that, it makes more sense to use a technology that is appropriate for that. And we're already using gRPC, and gRPC does that. So this whole proposal here is really to move the intercontainer communications between the core and adapters from Kafka to gRPC. Note that we also have a Kafka bus in the vOLTHA environment that we use to send PMs, to send other events. That Kafka bus will remain. I'm talking specifically about the Kafka bus between the core and the adapters. So here is an example of what exists today. This is the figure figure one that is on the screen there. So in the core, whenever we want to talk to the adapters, what we have today is we have the logic of the core internals there, and then we have a bunch of proxies, and we also have a request handler. Pretty much like when we send a message from the core to an adapter, we send it to an adapter proxy that take that message, format it in a certain way that we can send it on the Kafka. Then it's sent to a Kafka proxy. The Kafka proxy is the interface with the Kafka bus. It's the component that goes send it out and wait for the request and match the transaction IDs and send that back to whoever make that call. So those components like the adapter proxy, the request handler is the one that actually receives a message from the adapters. And you see the same patterns exist in the core as in adapters as well. Like you'll see like the adapters also, they have a request handler, they have in the case, instead of they having an adapter proxy, they have a core proxy. So this same pattern exists. So basically what we're doing a lot of marshalling and marshalling of data in order to publish that on Kafka. So far it works well. Like there's no, so far we have not seen a scale problem with this architecture. But we can do better in terms of performance, especially since we have adopted a point-to-point communications. And if we want to have also introduce things like encryptions on net communications, then having a point-to-point communication with gRPC makes sense in that case. So what the proposal is? The proposal is fairly simple in the sense of we are going to take all those proxies out and replace them with gRPC. So basically what we are going to have, like in this example, in the core, we'll have an adapter proxy. And here the details of the implementation is yet to be determined. Like this is an idea of how we're going to implement it. But the moment we are implementing it, maybe there are certain components that will leave in each, for example, maybe we'll have a separate adapter proxy only for core. There will be a core proxy maybe for each one of those components, or we'll have a certain part of it that will be sent to a library, and then just like the vOLTHA libgo, for example, and we are going to use those kind of features from there. But this is just an overall idea of how it's going to look like, in the sense of we'll have, whenever the core wants to send a message to an adapter, it will send it to an adapter proxy, which is pretty much have a bunch of clients, a gRPC clients, and the core will have a connection to each of the adapters. You will have one to an OLT adapter. If we have multiple OLT adapters, then it will have a connection to each one of them, and then it will have a connection to each one of the ONU adapters. Similarly, the OLT adapter will have a connection to the core and to each of those ONU adapters, but the ONU adapter will have a connection only with OLT adapter and to the core. So the ONU adapters, they don't talk among themselves. Similarly, the OLT adapter will not talk among themselves. So this is really point-to-point communications. Any questions on this proposal?
Do we need to replace the Kafka right now, or is this just for future?
This is for future, because at this time, like when we say now, like obviously it won't be as part of 2.5. It will be maybe 2.6 or post 2.6. One of the caveat of this approach is, well, we don't need to, but it would be good to have the open ONU adapter written in Go to be completed first, and then move and do that change. Because we don't want to do that change using the open ONU in Python, because that's a lot of code changes that we have to put in that Python code base that we won't use in the future. So that will be a waste of time. So it's this proposal really will go with the open ONU adapter in Go.
But don't we want to make this proposal change before we also do the security stuff? Else we're going to have to replicate all the gRPC certificate passing in Kafka.
Well, then the question arises, does the security stuff really need to be done within the vOLTHA components? Right now, our gRPC certificate business was really between the adapter and the agent inside the OLT, right? Because that is an external facing interface. Whether we need certificates or not between components, I would prefer to stay away from that, actually.
I would tend to agree with Suraf on this one. Within the core and the adapters and the WEF agent and things like that, I would avoid securing through gRPC. I would secure the outwards facing channels, meaning the gRPC endpoints that vOLTCTL uses, for example, so the northbound gRPC, and the southbound gRPC towards the OpenOLT. To me, those are the only two ones that we really should secure.
I guess that depends by where the operator are going to deploy the vOLTHA stack. Because if that's on an internal private cluster, then yeah, we can hold off securing those communication. If someone is planning to deploy vOLTHA on the cloud somewhere, then we may need to secure it.
The good news is moving to gRPC will give us that flexibility. If we need to do it, then we'll do it. If we don't, then it's there.
Great. I had a question on, are we planning to completely drop Kafka from the infrastructure, or still keep it around to push out alert and messages? Because I remember last week when we were discussing about the error handling, there were a few cases in which the only error reporting was done over Kafka.
Yeah. So those there will still be a Kafka bus for errors, for PMs, so events. Those will still remain. So this replacement that I'm talking here is really the communication between the core and the adapters. That's it. That's that Kafka bus. But the other Kafka bus for events, errors, and everything, that remain. That doesn't change.
So also between the OLT adapter and the ONU adapter, I guess.
Yes, OLT and ONU adapters. Yes.
So tomorrow, if we decide to implement the core in HA fashion, there are multiple instances per stack.
Mm-hmm.
So how would this change? So you would have gRPC interface between the cores if they need to communicate to each other, or how would this architecture extend?
We've gone beyond that design, right?
Yeah.
We have gone beyond that, but I mean, say tomorrow, I mean, if we, I mean, we have completely ruled out that architecture, or?
Yeah, I think we have rolled it out, and if we have to introduce HA, then we'll have to find some ways, some means around gRPC communication. The way there was so many potential of there were so many pitfalls when in HA per se. So that's why we chose to go with a way simpler deployment approach, the stack base. So I don't know if we will ever go back to the previous HA approach, or maybe we'll come up with a different, a new approach, but it will have to involve gRPC. I don't think it will involve Kafka.
And there's multiple aspects of what we've done around this, right? We said a single OLT per core.
Yeah.
Right. So even if we went to an HA approach, we could do multiple pods behind a single service point, which would kind of give Kubernetes level of, it's not real HA, but Kubernetes level backup, I guess. We could still manage that. So I think there are ways we could go about adding some capability around this, which wouldn't bring us back to where we started with, where we were trying to do sub 50 millisecond HA for API calls. So yeah, I think gRPC fits better even in those situations, to be honest.
Yeah, got it. Yeah, I think given this requirement, yeah, I think this might fit well.
Any other questions on this approach?
So is the only advantage would be the performance, or maybe there may be some other disadvantages using gRPC? Have you ever thought? One thing that I can think of is, so when adapter is started, the messages doesn't lost because Kafka stores them for a period of time. So even if an adapter restarts, it still be able to get those messages. So in gRPC, we will lose that, I guess.
Yes, that's correct. And to be honest, the Kafka persistency of messages per se, we have not really used that because most of the messages that we have today, it's we send a message, and then if either the other side responds or they say timeout.
Yes.
We don't really wait for that. And there are some messages that are very like time sensitive. For example, when we send a packet out and if the other end is not there, after a while, like even if that message gets resent, it loses meaning. So we have not really used that capability.
Yeah, and I have to say that in some cases we have seen the opposite effect with the messages being still around in Kafka. For example, I've seen a few times in the scale test, if an adapter restarts, then immediately receives some message on Kafka that is for a specific ONU, but the adapter hasn't rebuilt its cache yet, and so it crashes again because it cannot find that particular device handler.
What about in-service software upgrade? So, so if we implement the in-service software upgrades, then we may need to use the Kafka to not lose the messages.
Can you be a bit, maybe provide some more details about that?
So if I want to upgrade, let's say, OpenONU adapter, then if there are any incoming messages from the core or OpenOLT adapter, I shouldn't lose them. So we will probably need to think about a mechanism to cover the in-service software upgrades.
So there's a couple things there. One is that scenario different than if a component crashes when there's a request in flight?
Not actually, yes. It's still a restart, yes.
Right. So if we're going to handle crashes, then we need to be able to handle recovery in those situations.
Yeah,
So the upgrade is essentially the same thing.
It should just trigger a resync, right? That's already implemented today.
Yeah, and I think there are very few messages that won't be retried. Basically, only the operation that you do via vOLTHA, like create a device or enable it. Because every other packet in, packet out, or the flows, those will be retried by either the clients on their G or by ONUS.
Okay, I just wanted to point if there are any disadvantages.
Yep, makes sense.
Just to check, yeah.
Yeah, makes sense.
That was a good point to raise. Because I don't think gRPC or Kafka will make a big difference in those cases. It's more the code that is built around the interface, I guess.
And one big advantage actually moving to gRPC is currently the error handling that we get from when you send a request to an adapter or an adapter to a core. We send an error message, and the error message is very cryptic. Not everything being sent, not everything include the proper error code and everything. So going gRPC, we can go and fine tune that error message that we send out. So there are multiple advantages there when we go to gRPC. Any other comments on this? Okay. Then here's an example of a flow for adapter registration, and that remain as is. Nothing changed as with the way it's done over Kafka. Basically, what the way it works, and here the core and adapter proxy. This is part of the read-write core. I just put them separate just to show the difference there. So whenever the core restart, basically it will create a gRPC server. It's already have a gRPC server, but today what it's going to do, it's going to add a core adapter service. Pretty much this is the request handler. This is how an adapter talk to the core. So it will just have a bunch of APIs that the adapter can use to talk to the core. And then similarly, any adapter, when you start, they will have a gRPC server. They will create an iAdapter service. iAdapter meaning it's a set of APIs that the core will use to talk to the adapter, and also an inter-adapter service, meaning this is what a set of APIs that the adapter will use to talk to another adapter. So when they start, this is what they will have to do. And then the adapter will send a register message, just like today. It will send a register message to the core, meaning it will invoke an API on the core. If the core obviously is not there, the adapter will have to retry, just like today. And the core, what it does, there's two scenarios there. It's if it's first time it's seeing that that adapter, it will save that adapter. It will set up a gRPC client connection with the adapter. You just create that connection right away, and then it's done. So now from that point on, it has a communication with the adapter from the core to the adapter, and then the adapter will have to do something similar on its side to create that connection to the core. And if the adapter didn't exist before, meaning it was a restart, it does the same exact thing. It will reset that gRPC connections, and then it will do a device reconciliation. So the overall flow doesn't change as today. Like moving from Kafka to gRPC is just a mechanism of connection that has changed, but the rest of them remain as is. Any question on that? Okay, let me move to the next one. Multi-adapter instance support. Like currently we use, we have multiple ONU adapters in the vOLTHA stack, and a single core and a single OLT adapter. And that will remain as is. We won't change the mechanism, because today what we use a constant ring in order to have a ring where each node on that ring is an instance of the component. So in today's world, those are ONU adapter. If we have 10 ONU adapters instances, so each one of them will be a node on that ring, and then we use a constant hashing mechanism to map a device onto one of those nodes. So that technique will remain as is. Today we use a Kafka topic. Tomorrow, instead of using a Kafka topic to differentiate between those adapters, we'll use a gRPC endpoint for that. But the rest of the mechanism per se remain as is. It will still be done by the vOLTHA library, and yeah, no change there. Any question on that? No questions, no problem. By the way, like if you guys want, this is open to comments still. So it's even after this meeting, feel free to comment on any of those parts. On the core restart, the adapters will keep trying, and then until they can reconnect to the core. And if the call is done, there's not a device reconciliation doesn't happen because the adapter already have those information. But the call will wait for any synchronization messages with owners before processing from them. And here's a typical RPC request from the call to the adapter. Let's say we are sending a enable device to the core. So enable device comes in, the core update the device state in the KV store. We send the enable device to the adapter proxy. What it does, it talks to the vOLTHA library, says, okay, give me the endpoint for that device. It gets the endpoint, it maps that to a specific gRPC client that it needs to talk to, and then it sends that enable device to that specific adapter. And then it sends back, okay, I'm done with this request, but it's asynchronously wait for an answer. And when the adapter gets a request, it processes a request, sends back the response, and there you go. Finally, the call gets a response. It's either log or publish the response on Kafka, and it's all done. So this mechanism per se, this is what exists today. It's nothing has changed there except they instead of using Kafka, we're going to use gRPC. And the same thing happened with inter-adapter communication. This one will be a little bit more involved in terms of the code changes because there's a lot of messages that are more built in, not in the library, but more within each component, notably the OpenONU adapter. So those code will have to move out in order to adopt more a gRPC approach. So here's an example, for example, like an OpenONU vOLTHA sending an ONU indication to the adapter proxy figure out what is the endpoint, talking to the vOLTHA library, get the endpoint, map it to a gRPC client, and then send that to the specific ONU adapter. And your OpenONU adapter processes that and sends back the response. So the mechanism is similar to what the core is doing. So it will all be the same, except like I said, in the case of ONU adapter, there would be a little bit more work around that because there's a lot of code that is not in the library that is more embedded within the internals of the ONU adapter. Any questions so far?
So normally we are using from topic and to topic to send back the replies. Will we use this same mechanism or something similar like?
We won't need that kind of mechanism in the sense of we'll have a gRPC connection, like for example, a component sending over a gRPC client to the other end, a request, and it's not closing that connection until it receives a response back. So we don't need the from topic to topic as we had before.
Even if we are using multiple vOLTHA adapters and ONU adapters.
Yeah, we won't need that because that should all be done using the constant hashing mechanism that we'll have. Pretty much like a device would be mapped to one core instance, to one OpenONU instance, and one OpenVOLTHA instance.
Oh, in the case of if the OpenONU adapter in Golang.
Yes, exactly. Yes.
Okay.
So if I understood.
Go ahead.
Oh, sorry, I don't know if Serkant, you were done.
I'm finished, yes.
Oh, okay. So are we basically planning so that every component is both a gRPC client and a gRPC server?
Yes, that's correct.
Okay. Do we see space to use gRPC streams instead of having a component being both a client and a server?
I was thinking about that. The only problem with streams, like we have like gRPC stream, some gRPC stream between the auth agent and the core is mostly around packet handling, packet in, packet out. Some of it we may decide to have it. The only problem with that is like once you have streaming, you need to always make sure that if the connection is broken, you have to redo the connections, and then you have to send an initial message to tell the other end, okay, you need to open your stream as well, so I'm going to send you something. So the mechanism is a little bit more, I won't say complicated, but it's a little bit more complex. And also, like once we have streams, are we going to send only one type of messages or multiple type of messages? For example, if we open a stream for packet in or packet out, so we know it's only packets that we're sending it. And then for those kind of messages, it's okay, but are we going to open a streams that will, where we are going to send messages like adopt device or disable device or add port? Then in that case, like we're getting away a little bit from the RPC world. We are trying to kind of marshal multiple messages in that one stream. So in that case, it doesn't make sense. But if we find that having a stream for things like common messages like packet in and packet out, it will be much faster for processing, then maybe we can choose that. But so far, honestly, like even using the Kafka messaging, we have not had a problem with those kind of messages, like the packet in, packet out. And remember, like we are marshalling everything over Kafka and have not seen any issues with that. So maybe we can still just go without streaming. What other people think?
Yep. Yeah, no, I agree. The delay we are seeing in the packet in, packet out are not because of Kafka, but because of information that we need to look up to send the packets in the right place, and that will probably not change with gRPC or with a stream.
Mm-hmm.
But it was just something that I was thinking about, because having everything that is both a client and a server seems a little bit confusing. So maybe having streams is just a way to make clearer who is responsible for the communication, who is the server and who is the client. But yeah, I haven't thought a lot about it. It's just something that came to my mind right now.
Yeah.
Seems like
yeah, it's a good point, because I was thinking around that as well. So there's a lot of implementation details that needs to flesh out to figure out like which approach is better than the other approach. But in general, my preference would be like not to have streaming, but it's yet to be determined.
I tend to agree with Theo that in some cases might make a lot of sense to have a stream. In some other, it might not. The failure scenarios and error scenarios that you outlined are also a valid concern, because you might send a request on a stream, the operation might happen, but you might have lost the response, so you would not need to send it again. So that's something that we need to take into account. But for example, in the case of operations such as flow add and flow remove, to me it makes a lot of sense to use a stream, because you could, instead of serializing the whole set of flows, you could serialize it per flow, send it on the stream, and you would apply it, and then you could come back with a response on a per flow basis, and you could actually know a lot better what flow failed and things like that, maybe.
But
so
I actually see flows way more like an RPC kind of request, because that you send a flow, you get the response back. You send a flow, you get the response back.
Yeah, but you.
While
Sorry.
Well, you can divide the flows and make one request per flows, even with RPC if you want to. I see a stream more for like packet in, packet out, where we don't do a lot of operation on the packets. It should be just like a pass through, and it makes more sense to have an open connection, because that seems to me should be a quick exchange, and vOLTHA really just pass the packets out.
So So in my opinion, a good rule of thumb is that if you're not ever expecting to return errors, streaming might make sense. Anywhere where you might have an error, you don't really want to use streaming. So that basically divides packet ins, packet outs. There's no errors for those. But for anything that's a request where you're changing tables or anything of that sort, those are all going to possibly have an error come back. So you want to use proper gRPC requests.
That's a very good summary of streams versus RPC. I think I'll steal that from you.
Yeah, that's a very good one.
Hey, thank you.
Cool. Any other comments around this? Okay, so here I put some overall some effort required to move from Kafka to gRPC, and this is really like I use terms like small, mediums, but it's really like it's up in the air. It's like there's no scientific means that I use to figure out this out. So, but pretty much what I meant here is the gist of this is the places and the type of changes that we have to do. So we'll have a lot of changes around the protos because the way gRPC is designed, we can't have like multiple parameters as we are doing today when we send a message out. So we need to create like a bunch of messages for the different kind of message tag that we're sending it out. So we'll have to have things like also we need to create all those different RPCs like for I-adapter, inter-adapter, co-adapter, all those protos. So there would be a lot of changes on the proto side. We'll have changes on the vOLTHA library. This is more around the consistent hashing because now we're going to use gRPC endpoints. There will be changes on the core, and that's most of the changes around like using gRPC, about replacing all those proxies with Kafka, and also replacing the request handler with a new core adapter gRPC service. And the OpenVOLT, it's very similar to the core. We'll have gRPC related changes where we are going to replace Kafka and replace the request handler as well. And also on the OpenVOLT, and they will also need to implement the inter-adapter gRPC service in order to communicate with the ONU adapters. And OpenONU adapter is the same thing. They were as the OpenVOLT, so there will be a lot of changes there. And as I mentioned there, like the recommendation is to make that change when the OpenONU adapter has migrated to Go, instead of doing that on the Python version. And then there will be other changes like on the Helm charts, and obviously there's a lot of work around integration testing there to make sure that everything keeps working, and all the tests that we have pretty much done will need to be redone in that kind of environment. So that's pretty much it. Any other questions on this?
Have you also think about using a service mesh like Istio? I do not have any experience with that, but just asking.
No, I've not have looked at it, but I've not considered it in this case, because I think this is this is fairly a simple implementation, so I didn't want to add too many other service mesh like Itch.io, for example, in this. I think that may add a little bit more complexities to the overall design. Just an opinion. I didn't really try it out.
Yeah, it seems a simple design, but in the way we may see some complexities.
Potentially, yes.
Yeah.
Any other question? Okay, this document is open it's still open for review. So please feel free to add comments on it, and I'll take a look at it. So if there's no other questions, no other comments, then I'll give it back to you, Andrea.
Yep. Thanks, Ken. Oh, does anybody any other comments?
Yeah, one Raghu
Okay.
here. One comment is like, is it possible to add some kind of failure scenarios where the let's say any adapter instance is not available, and at that time how the action will be taken care by the other party? So it will be good if you add one more failure scenario just to demonstrate.
Okay, sure, I'll add that.
Sure, thanks.
Okay.
Any other questions? Okay, back to you, Andrea.
Yes. Okay. So thanks for that, Ken. That's much appreciated.
Yeah.
You're seeing the right screen. Well, that's much appreciated. There was no other topic on the agenda for today. Does anybody have anything else that they want to talk about? Okay, then if not, please do take a look at the certification manager. I'll make sure to come up with a rough implementation proposal for next week, in order around this one, so we can discuss it with a little bit more detail. And please do take a look at the document that Ken just shared. Any comment are much appreciated. I see a few people that already did put comments on it, but if you have any thoughts or any ideas around the things that Ken put down, it would be very much appreciated if you could put them in the document, because there we can better keep track of them. As Ken said, this is really something that it might not even be for 2.6, but being a fairly hefty set of work, we might as well start planning for it, because it would take some time. And there's, we didn't get to it in the document, but there are some sections that talk about how the implementation might be done. There are some comments that discuss that. So please do take a look at those too. Okay, anything else?
Yeah, just a reminder, please do revisit Jira and take a look at your stories that are listed as 2.5 and potentially move them.
Yes, thanks, Surf. As I said, the link is there. These are all the 2.5 stories that we have. As I said at the start of the call, please do review them, and please do move out anything that is not either a bug or a test. Those two can go in. Rest of it cannot go in 2.5 because we're already past code freeze. So anything that is not related to bug fixes or tests, please take it into 2.6 or future. Everything else, just leave it in there and make sure to update the status of your stories. Thanks for that. Okay.
Thank you.
Thanks, everybody. Cheers.
Thank you.
Take care.
Thanks.
Bye.
Bye.
Bye-bye.